Let's talk about 2012. We saw quite some amazing weather events in 2012. Angela, Fritz, you have on your blog, you had sort of a greatest hits of 2012. So run us through all the things that happened, from the fires to floods, et cetera, in 2012. There's some amazing video footage as well that you have.
Everyone loves a good top 10 list, right? So specifically, relating to what we were just talking about, in July of, or was it August of 2012?
The Watson River.
Yes, Greenland experienced melting that was unprecedented in satellite history, at least. And 97% of the surface area of Greenland was warming at one time, and the result was that the Watson River and another river in Greenland, which tends to be where the melt water comes off in the summer, because Greenland does go through a melting phase in the summer, was double its prior record. And so it took out bridges. There's videos on YouTube of just this raging river. And when I saw that, I have to say there are very few moments in climate change, because it happens slowly and over time, that you kind of grip your chair and think, oh gosh, this is really big. And that was a big moment for me. I think that might have been a bigger moment for me even than Hurricane Sandy, which was another item from last year, or the wildfires, or even the drought. That was kind of one of those, this is happening right now moments.
And the reason you got that lump in your stomach is because you understand that that's a visual conveyance of data, and you understand that if that starts to melt really fast, what that means for all these other things.
Right, and there's this idea that we don't know when the Greenland ice sheet could lose its stability and, literally slide off the continent. There are some scientific nuances to that, but the more that melting, I could just imagine it getting under the ice sheet, between the continent and the ice sheet, and just lubricating it. And then at what point do you start to see this ice slipping off into the ocean? And we could have already hit that point of no return with Greenland, and we might not know it for a few years down the road. And so when something like that happens, it's definitely a wake-up call, even for climate scientists, I think.
The late, great Stephen Schneider, climate scientist, was here one time and said that the tipping points are out there. We don't know where they are, and we may not know we've crossed them until 50 years after we've crossed them. Let's talk a little bit about storms and droughts, how this may come home directly to more Americans. We saw some fantastic droughts and storms in 2012. Let's talk about the impact of those, and is that something we're going to expect more of?
Right, so the Great Drought of 2012 was as bad as the Dust Bowl. And at one point, 62% of the United States was in more than a moderate drought. So that's what I would call, an impressive drought across the United States. And as of late February, unless we see some top 10% event in March or April, we're going to continue that drought into 2013. And it's hard to tell at this point how bad it could get in 2013. So again, we're looking at multi-year droughts now. This isn't just a single year event. And again, the heat wave of last year was another reason for that drought, and they amplify each other. They kind of feed off of each other, the drought and the heat. And we could be seeing more of that this year. There was some very interesting research just published by Jennifer Francis at Rutgers, where she found that Arctic sea ice loss and the greening, so to speak, of the Arctic and the continental areas around the Arctic could be changing how the jet stream pattern works in effect. It's slowing it down, it's making it more amplified. And what that means is that we are seeing more extreme weather, and we likely will continue to see more extreme weather. And not only that, but it'll probably last longer because the way the jet stream works, the jet stream exists because the tropics are warm and the Arctic is cold. And it's strengthened by the difference between those two things. So the warmer the Arctic, the warmer the tropics, the colder the Arctic, the stronger the jet stream is. So what happens when you make the Arctic warmer, but the tropics don't warm up as much. That, you know, and that's essentially what's happening here. You're weakening the jet stream, so making it slower, and then you're also making the ridges and the troughs longer as well. So you're getting those extremes, and you're getting longer extremes.